So continue in chapter 5, chapter 5. And we are going to take some examples about applying the laws of Newton and how to apply them to solve problems. So the first one, it may face us in the problems, اللي هو particle in equilibrium, and this equilibrium is static equilibrium. That means velocity is equal 0. Velocity is equal 0. Because we said before equilibrium, we can have static equilibrium and we can have a kinetic equilibrium. So this one is static equilibrium. Summation of forces is equal 0 and velocity is equal 0. طيب, in this situation we draw our object as a point, and then we have gravitational force and we have our tension. Summation of forces, I'll just repeat what he's written. Summation of forces is equal 0. In terms of vectors, this is tension minus mg is equal 0 plus mg is equal 0, because those are vectors. And that means in the x-axis they are equal to 0, and the y-axis they are equal to 0. In the x-axis there is no forces, so in the y-axis we take the component. So we assume up is positive, down is negative, so it will be tension is up minus gravitational force down, or the weight down, is equal 0, and this will lead to the conclusion that tension is equal to mg. This is the physical part of this problem. Now you may have, he will ask you for numbers, or he will give you, for example, the mass, and he asks you for the tension or whatever. But the physical part of this problem is this equation. That's the physical part. And most of the marks when you solve a problem will be on the physical part of solving the problem, the equations of physics. The equations of physics. Let's take another example. An object, which is this box, and this student is applying a force from left to right, and suppose we want to calculate the acceleration of this box. So we can start with this equation as a general equation, and then we analyze it. Summation of forces in the x-axis is equal 0. Summation of forces in the y-axis is equal 0. In the x-axis, how many forces do we have? We have only one force. You can call it tension, for example. Or we can call it force of the boy. طيب, in the y-axis we have the gravitational force pointing downward. Let me have two colors. So this is the gravitational force. Let me enlarge it, because we said two forces. We have action and reaction. Action is applied on one object. Reaction is applied on the second, from the second object to the first object. So the action force box on ground, we can say, and we have a reaction force. We name it F is equal ground box. Action and reaction. And we can write it in this diagram. Summation of forces in the y-axis is equal 0. And from the previous example, it's just a tension is equal mg, and in this situation there is no rope, but we have a normal force. We have the normal force, then the normal force is equal, be careful, no vector, just quantity. What's this? Normal force is equal mg. You are right, summation of forces, because we have only one force, so we just remove the 0. And you are right. Who is this? Dawood. أحسنت يا Dawood. We analyze forces in X, analyze forces in Y. In X, we have a net force, and it will cause for F is equal ma. And in the Y-axis, because it's not moving, summation of forces is equal 0. أحسنت يا داود. شكرا. طيب. Now let's come to this situation. Of course, up to now we didn't mention anything about friction. We didn't say anything about friction. Friction, we are ignoring friction up to this point. طيب, suppose that we have a problem, and in that problem we don't have only the book, but we apply some pressure on the book. So we apply some external force on the book. So how we can solve these kind of problems? Well, this is the book. So the book gravitational force is mg, and we have the normal force, but now we applied an external pressure, so an external force. We apply an external force on the book. So now in the negative direction, we apply an external force. So we call it F. So now we can draw our object like this. So this is mg. this is the applied force, we call it F, and then we have the normal force, which is plus F plus mg must equal to 0. And this is summation of forces is equal 0. Because the book is stationary, it's in static equilibrium. No component in the x, we have only a component in the y, so then summation of forces in the y is equal 0, and that is equal normal force up, applied force down, gravitational force down, and that is equal to 0. Yani normal force in this situation is equal F plus mg. So if you have a problem to solve it, and depends on the problem, he can give you the mass and the gravitational force, gravitational acceleration. He can give you F, he can give you the normal force, or he can give you two of them and he asks you to calculate the third one, whatever the problem. But when we analyze it, the key to solve this kind of problem is those physics equations. And if you have such a problem that you need to solve in the written exam, most of the marks will be here. Most of the marks will be here. Now, if you do, after you write the equations correctly, if you do a mathematical error, well, I will deduct only a small portion of the mark. However, if you do any mistake in those equations, the whole mark is gone. Abdurrahman is asking, is it always 0 to be balanced? حكينا يا Abdurrahman, we have two situations. Situation 1 is static equilibrium. Static equilibrium. That means summation of forces is equal 0. That's the first condition. The second condition, in velocity is equal 0. The second situation, summation of forces is equal 0 and velocity is constant. That's the two situations. Now, if you have a force like the previous problem and the common problems, if you have a net force, then you have a net acceleration. If you have a net force, then you have a net acceleration. And that condition of velocity is equal 0 or velocity is constant, it comes from the fact that we cannot solve the Newton's law unless we have inertia frame of reference. That means acceleration of the frame of reference must equal to 0. Either velocity is equal 0 or velocity is equal constant. So the acceleration of the inertia system must be equal to 0. So those are the two situations. If the inertia frame of reference does not exist, you cannot solve those problems using Newton's laws. طيب, let's take another situation. So this is the first situation, that summation of force is equal 0 and velocity is equal 0. So the object is not moving. It's inertia frame of reference because acceleration is equal 0. Acceleration of the system, the inertia frame of reference. Here we have a net force inside the system, inside the inertia frame of reference, and that net force will result into an acceleration inside the inertia frame of reference. طيب. Let's take this problem, and this is a typical problem. شو يعني typical؟ يعني when you open any physics 1 book, you'll have this kind of problem. When you open any physics book, you'll have this kind of problem. Numbers is different, angles is different, situation is different, but always we end up with a situation like that. I will give you a minute. Read the problem, stop the recording, and come back to you after a minute. Okay, so let's start to solve the problem and write our information. So, as we said, let's draw our problem. So here is the point where we have, after it, we have two wires. It is hanged like this. And then we have another wire, as you can see. So draw it like this. So this is T3, this is T2, and this is T1. And as we mentioned in the previous lecture, we said the direction of the tension can be either way. Either way. You can write tension this way, or the opposite, but then it needs to make sense, your direction of tension. It's just to help you imagine the problem. Here we have theta 2, which is 53. So this one is 53 degree, and this angle is 37 degree. That means this angle is also 53, and this angle is also 73. What other information? We have the mass, not the mass, the weight. Weight is equal 122 Newton. طيب, let me repeat again. This is a typical problem. So far, I will write the general equations, and then I will decide what is the unknown, and what is the required in the equation. But depending on what he is asking me to do, well, it depends on me writing the equations correctly. If you write the equations correctly and then you do a mathematical mistake, then the deduction will be small. However, if you do any mistake in the physics equation, everything will be wrong. And the whole equation will be wrong. And most of the mark will go. So let's write our equations. Here we have static equilibrium. Here we have static equilibrium. Okay, so that means summation of forces is equal to 0. And then we go for forces in the x-axis, and we go for forces in the y-axis. So in this equation, nothing is moving. So summation of forces in the x-axis is equal to 0. Summation of forces in the y-axis is equal 0. So let's write our equation in the x-axis. So this is x-axis, and this is our y-axis. طيب, in the x-axis, so let me just put a line, change the color. Let us see. We have in the positive x-axis, we have the component, the x component of T2. X component of T2. What is the x component of T2? It is T2 cosine 53. طيب, and we have in the negative x-axis, so put a minus sign, T1 cosine 37 degrees, and that is equal to 0. Now, let me repeat. If you do a mistake in the sign here, the whole equation is wrong. If you write the equation correctly and you do a silly mathematical mistake, deduction will be small. But you need to write the physics equation correctly. So in the x-axis, so this is our T2 cosine 53, and this is our T1 cosine 37. Any question? So this is our equation 1. No, you can't write cosine 143. No, you have to write it in, as I said, 37. Any question? طيب. Now, summation of forces in the y-axis must equal to 0. Let's see the forces. Let's see the forces. يا داود, You are missing 1. أيوة. Correct يا يمان. We have T3 minus. So here I assume downward positive. I can assume downward positive. According to my method of naming the equation, I will assume downward is positive, upward is negative. So T3 minus T2 sine 53, and we have minus T2 sine 37 is equal to 0. T1. أحسنت. مين هذا البطل؟ أحمد. أحسنت يا أحمد. Thank you يا أحمد. And where is T2? We can draw it. This is T2 sine 53, and on top of it, black color, on top of it, this is T1 sine 37. So 2 forces are pointing up, 1 force is pointing down. So this is my second equation. If you write the equation correct, you will get most of the mark. If you do a mistake in the sign, the equation is wrong and you lose most of the mark. So it is imperative that you know how to write the equation correctly. We can consider a third equation, and T3 is equal 122 Newton. You can assume that is equation 3. So what does the traffic light remain hanging in the situation, or will it break? So he needs from us to calculate T1 and calculate T2. طيب, let me emphasize again. What I am teaching you is how to write the physics equations. Now, how to solve those equations to get to the number, that is the mathematical part. And personally, I will not deduct a lot of marks if you do a mistake in the mathematical part of the equations. Most of the mark will go for those equations. Well, your colleague Yaman is saying that he wants to reverse the sign. Minus, well, if you reverse the sign, it will be minus, let me write it, minus T3 plus T2.
I think T3 is like negative. It does not mean like make it negative.
Is equal to 0. It's the same equation. Those two are same. What's your question, ya Yaman, again?
Assalamu alaikum, doctor. Can you hear me?
Yes, I can.
Doctor, I meant we should change T3 with FG because T3 here is the tension and it should be pointing upwards.
No, tension has no direction, yeah, brother. Tension has no direction. Remember when we talk last lecture?
Doctor, so tension is not the same as the natural force, the normal force, we call it.
Read. Magnitude T of that force, tension, in the rope, it's a scalar quantity. What's the meaning of that? يعني, depending on what are you solving, tension could be considered up or considered down, considered to the right or considered to the left. So if it is tension, it will not dictate for you if it is up or down. But if you assume a direction, you need to be careful about other signs. يعني here we assume up is negative, down is positive. Here we assume down is negative and up is positive. Those equations, mathematically, they are the same equation.
Okay, doctor, thank you.
So what I'm teaching you is how to write those physics equations. Now, how do you want to proceed to find T1 and T2? It's up to you. How do you want to proceed to find T1 and T2? It is up to you. If you do a mathematical mistake when you solve those equations, I'll deduct a small amount of mark. But if you write those equations wrong, in terms of cosine or sine or minus sine, the whole thing will be wrong. So do you want me to go with you and solve these problems to find the T1 and T2? Or you'll do it on yourself, or your whatever you are used to do? Okay, so here is how I will solve it if I am in your place. And again, it is not necessary that you follow my way to solve those equations. That depends on your mathematical experience and whatever you are comfortable to do with. Even if you do a mistake in the mathematical solution of those equations, I will not deduct a lot of marks. I will deduct a lot of marks if you do a mistake on those major equations. طيب. So I will take equation 2, 122 minus T2 sine 53 minus T1 sine 37 and is equal to 0, and this will lead to 122 is equal. I will just move them. I want to solve them. 37. Now I use equation 1 to write as T2 cosine 53 is equal T1 cosine 37. And from there, I reach as T2 is equal T1 cosine 37 over cosine 53. Meaning I will just put cosine 37 and cosine 53. What is this value? Can somebody calculate it for us? So T2 is equal T1 and then multiplied by 1.32. Well, I go back to this equation. Now I will replace T2 and keep T1, so I end up in this equation with only one unknown. No, that's wrong, yeah, Ahmed. It is 1.32 or 1.33 depending on يعني على ذمة يمان قرب صح ولا ما قرب صح. يمكن 1.33. No big deal يعني. طيب, so let me just color it. So this is T2 and this is T2. So now I write this equation to become add 122 is equal T1 multiply 1.32 T1 sine 53 plus T1 sine 37. يعني 122 is equal T1 1.32 multiply by sine 53 plus sine 37. And what is this number? T1 is equal, any volunteer? $73.7. لأنه أنا طالع عندي 73.3. طيب 73.7 Newton, and here let's put some mark إنه check the numbers. يعني use your calculator. If you have a different number, then it's not a big deal. What's the number in the book? Yeah, 73.4. So I think my number is closer than your number. So let's put it 73.3 Newton. It could be that, Yaman. Yeah. Wallahi, midterm, I think we will do a meeting. Professors who are teaching 191, we will have a meeting soon, inshallah, to tell you when is the midterm. Next week, inshallah, we will tell you. طيب, now I have T1 and also I have T2 from previous equation, but T2 is equal 1.33 T1, so that means T2 is equal 97.5 Newton. طيب, if a student, for example, solved and find first T2 and then find T1, correct, no problem. No problem. طيب, if مثلا a student did some mistake, مثلا like your friend, here instead of sine 53 degrees, he was on the radian, and then he has a funny number here and a funny number there. Well, I will deduct small mark because that's a mathematical mistake and we are teaching physics. Like if it is a mathematical course, yes, I will deduct heavily. But I am teaching physics and I will deduct heavily on those equations. 1 and 2 and 3. Well, 3 is not an equation, but on 1 and 2. Those, if you do a mistake there is no tolerance of mistake. Sines and cosines has to be correct. Well, sines plus or minus has to be correct. If you do any mistake on those equations, you lose big time. Because all the physics in those equations.
Doctor,
تفضل.
I don't get in the first equation when I told you if we could put T1 cosine 143 instead of cosine 37 is wrong.
Well, listen
Like,
to
I
listen.
could,
Yeah,
like,
listen.
inverse the sign and it will be the same.
Yes. Well, listen to me carefully.
Okay.
Listen to me carefully. When you are starting to learn, it is better to follow a strict and methodological way, so you don't do mistakes. Like in this example, yeah, it is clear in 143, it's if you have cosine 37, it will be positive. 143, it will be negative, and then you write it a plus sign. Yeah, but how about if we have another problem, and then if you do a mistake, the whole equation will be wrong. If you do a mistake, the whole equation will be wrong. If once you are used to use the equations and you know exactly what are you writing, and now you are professional, you solved like 10, 15 problems, yeah, if you want to write it instead of cosine 37 minus cosine 143, yeah, I'll accept. But at the beginning, just let's be strict so you learn. Because here it's not the 37 or the 43. At the end of the day, here you need to tell me that the component of T2 in the x-axis is opposite to the component of T1 in the x-axis. That's what I am after. So if you want to tell me that information using cosine 37 or cosine 143, I'll accept. But if you do a mistake, everything will be wrong. So it's a risk that you take it on your own. يعني مين اللي سألني، أحمد ولا عبد الرحمن؟ شو اسمك؟ عفوا يا بني. ايش شو اسمك؟
عادل.
عادل. يعني يا عادل زي كأنك بدك تتعلم سواقة. أول ما تتعلم سواقة بدك تلتزم يعني على الشعرة، وبعدين بتكون مرتبك وبتطلع على المراية الشمال وبتطلع على المراية اليمين، وما انت بدك تطلع على المراية اللي فوق، ومرتبك وخايف وأعصابك مشدودة. طيب بس تاخذ ايدك خلص بعدين ما انت شايفهم كيف اللي بيحكي على التلفون واللي باكل سندويشي وهو بسوق واللي مش عارف ملتهي واللي جاعص. شايف كيف؟ عاد صعب هاي نترجمها هسه. فهو as a starter stick to the rules. تمام؟
Okay.
When you are professional إن شاء الله do whatever you like.
إن شاء الله.
طيب suppose that you insist and you write the equation. عاد حمد جاعص يعني جاعص يعني مضطجع. جاعص يعني مضطجع يعني مش قاعد على الكرسي هيك 90 degree angle. بتشوفوا الشباب كيف هم بيسوقوا خاصة تبعين لاند كروزر. الشباب لما يسوقوا لاند كروزر بيكون هيك جاعص مضطجع على هذا مش انه يعني منتبه متكئ. لا أكثر من متكئ يا عبد الرحمن. هلا طيب أنت كتبتها في طريقتك وأنا لما أجي أصلح وجدت إنه طريقتك صح حقبلها ما في مشكلة. طيب جيت أصلح لقيت إنه أنت عملت خطأ تافه وسبب إنه المعادلة كلها غلط راحت المعادلة كلها. فانتبه لهاي الشغلة.
تمام.
Other question. طبعا لاحظوا pay attention إنه we wrote the equations. This is a general solution and we don't know yet what he's asking for. So those two equations can solve anything in the problem. In this specific problem, he gave us T3 and he wants from us T1 and T2. In another problem, he will give us T1 and T2 and ask for T3. Or he will give us T3 and T2 and ask us for T1. Whatever the question, it will be the same method. The same method. We write the two equations and then we solve them. طيب. Let's go for another typical problem اللي هي inclined plane. Inclined plane. So read the problem. I'll give you half a minute. So let me know when you read it. طيب. الحين you will find again يا جماعة you will find this kind of problem in any physics book that's teaching physics 1. That is an object on an inclined plane. And he asks us to calculate whatever acceleration or speed or final speed or whatever, but it is on inclined plane. So this is also a typical problem that you will find in all books. So let's try to analyze it. So free body diagram, we assume the car as if it's a dot. It can be a car, it can be a box, it can be a man, it can be anything, but something on an inclined plane. So in this situation, what we are going to do, so here is the ground, here is the inclined plane, this is our theta, and this is our object. So we have mg. Pointing downward and perpendicular to the surface of Earth. So this is 90 degree. أيوة الحين في عنا X component for this force and Y component of this force. And why X and Y component? Well, because in these kind of problems, we assume that this is the X-axis and perpendicular to it is the Y-axis. This is a 90 degree. So now, this is theta, this is phi, and this is theta. We need to analyze the mg to two components. The first component in the x-axis and the second component in the y-axis. Let me choose another color. Okay, orange. طيب يلا. What's this component in terms of mg? mg and cosine theta. This is mg. Let me just erase it from here and write it beside its original. This is mg. So this component clearly mg cosine theta. And this component clearly mg sine theta. This is mg and this is theta. So what's this component? The orange one. It is mg cosine theta. And what is the component, the green one? It's mg sine theta. Everybody is convinced, because I will not spend this time in each inclined problem to convince you that this component is mg sine theta. And Yaman, the first time, take your time. No problem. We'll spend enough time to show you and make sure that you are convinced. But after that, we'll just assume that I explain it, and if you are confused, go back to the video and convince yourself. Farhan, ya Farhan. Again, ya Farhan, this is mg, the component of weight. Do you believe that, Farhan? The blue arrow is mg. Ya Farhan? طيب. Now, we do it like this so you can see it easily. If this is mg, what is the orange component? The orange component is mg cosine theta. And what's the green component? It's mg sine theta. What is theta? This is theta and also this is theta. Well, summation of the angles of a triangle is 180. So this is theta and this is phi. This is 90 degrees. And again, this is 90 degrees. And this phi and theta is 90 degrees. So that means if this is theta, this will be theta and this will be phi. Big triangle and small triangle. Any question? Because after that, in any inclined plane, right away I will write the component mg sine theta for the acceleration, and for the normal force, it's mg cosine theta. That's it. I will not explain it anymore because already we took our time. طيب. So we align our tablet again. So in any, this is a typical inclined problem. Any inclined problem, you will have acceleration mg sine theta. And this is the magnitude of the acceleration and the direction parallel to the x-axis. And you have the normal force, the magnitude of the normal force is mg cosine theta. And it is pointing perpendicular to the x-axis, not perpendicular to the ground, perpendicular to the x-axis. So this is a typical problem where the acceleration is mg sine theta and the normal force is mg cosine theta. While I'll keep insisting on the normal force because we are going to use it when we start to talk about friction. But for the time being, we just need to know that normal force is equal mg cosine theta. mg sine theta is a force, or mg cosine theta is a force. Well, يعني if you want, you are right. مين هذا اللي داود برافو عليك, شكرا. So here M, here M, and we can just write it like this. A is equal G sine theta. شكرا يا داود. تفضل يا عادل, عندك رافع ايدك.
كنت بدي احكي اعلق على نفس هاي النقطة وبالنسبة للام كمان.
شكرا لكم جميعا. لانه الام جي يعني فورس والاي اكسلريشن لازم يكون في ماس. هلا انتو يعني من باب ذكر الشيء بالشيء, لاحظوا انه force is equal ma, معناته الفورس is equal m g sin theta. وفي عنا for a small force, for a small mass عفوا, وفي عنا a huge mass كمان is equal huge mass is equal g sin theta. لاحظوا انه mass will cancel with mass and we end up for small mass A is equal G sine theta. For big mass, also A is equal G sine theta. يعني it does not matter on the inclined plane if it is a small car or a tank or a stone, all of them, the force acting on it is A is equal G sine theta because the mass cancel. كويس اللي من باب يعني ذكر الشيء بالشيء. طيب in this find the acceleration. خلاص acceleration is equal G sine theta. والnormal force mg cosine theta. طيب let's move to another typical problem. Also, you can find this kind of problem in any or in almost any book that is teaching physics 1. This is a typical problem. What is the typical problem? You have two objects of different masses and the force is applied from one side. And he wants you to calculate the contact force. The contact force. هاي اللي هي شو نستخدم اللون؟ نستخدم الأخضر. Contact force. This is a typical question. You will find it in most books that teach physics 1. شو يعني؟ يعني most likely you will see it in the exam. The contact force is the force between the two objects. So we have two objects attached to each other and we apply a force from object number 1. So the question is, what is the contact force between M1 and M2? You are not pushing directly M2. You are pushing directly M1 and M1 is pushing M2. And in some problems you will find M3. M2 is pushing M3. We want the force pushing M2 and that force is called contact force. Contact force, that they are contact to each other. And again, this is a typical problem you'll find in most books and most probably you'll see it in the exam. طيب, how to approach these kind of problems? So let me explain it in this way. Suppose that we have a surface, frictionless, and we put on that surface a block. And that block, let's assume that it's 15 kilogram. And for simplicity, we apply a force, and force is equal 15 Newton in the x-axis. Correct? So, yalla, what's acceleration? Is equal m is equal F divided by m, and that is 15 divided by 15 is equal 1 meter per second square. Clear? Easy? طيب. Now I will have the same block, same exact block, same exact force, but now I separated the block into two pieces, 5 kilogram and 10 kilogram. Question is, what is A now? Will it make any difference? Ahmed said 1.5 for the 10 kilogram. No, yeah, Ahmed, that's wrong, because صحيح, correct that I separated them, but they are still in contact, which means both of them must have the same acceleration. The 10 kilogram cannot go faster than the 5 kilogram because it's in front of it. So the 10 kilogram and the 5 kilogram must have the same acceleration, which is very clear, as your friends said. It's 10 plus 5, oh sorry, it's 15 divided by 10 plus 5, which is 1 meter per second square. طيب, let's now use the second Newton's second law to calculate the contact force. Watch carefully. Apply it to this object. F is equal ma. What's the mass? 10 kilogram. What's the acceleration? 1. So that means that is the net force applying on the 10 kilogram object is equal 10 Newton. The net force is 10 Newton, but I am applying 15 Newton, and the net force is 10. So that means I must have 5 Newton coming from the blue piece of mass. So this is 5 Newton, and this is 15 Newton. 15 Newton minus 5 is 10 Newton. That means, يا عادل, the contact force is 5 Newton. طيب, let's solve a Newton's second law for the blue object.
Doctor, I just have a question.
تفضل.
We already found the net force that the box exerts on the blue, which is 10 Newton. Why do we say
10 Newton on the green box, not on the blue box?
and now you find from the blue to the green, it's 5.
From the blue to the green, it must be 5, or Newton's second law does not apply. لأنه Newton's second law for the green block says that the net force on the green block must be equal MA. We know the mass, that the mass is 10, and we know for sure that the acceleration is 1. So object 10 kilogram, the green object, feels that he is receiving 10 Newton only. But we are sure that we're putting from the left to the right 15 Newton. That means the green object must receive 5 Newton from right to left. And that is correct because MA, and we have 5 kilogram, 5 multiplied by 1, so that is the net force on the blue object is 5 Newton. That means the green will consume 10 Newton and will pass 5 Newton. So here, contact force well, you can start with the small object because the small object must receive 5 Newton. And then you go that the small object received 5 Newton. That means the big object received 10 Newton. You can do that. Contact force is not the net force. Contact force is the force between object 1 and object 2, between the 10 kilogram and the 5 kilogram, between the green object and the blue object. A green does not take 7 from the left, must take 5. Why 7? Applying Newton's second law, acceleration is 1, mass is 5, so that means 5 Newton. Exactly, it's the force. The force of blue on the green is 5. Blue on green is 5, green on blue is 10. The 5 Newton, the blue, it's the force, the reaction force from the blue object on the green object, because the green object is putting an action force on the blue object, which is 5. So the blue object will put on the green object a reaction force of 5. This is the acting force, the green one, and the reacting force is the blue one. اتفضل يا عادل.
Has like net power of 10 Newton. So this 10 Newton affects the blue box. Is that right?
علي صوتك شوي، صوتك بروح وبيجي.
طيب زي هيك واضح؟
هيك ممتاز.
تمام. What I was saying is the green box has a net force of 10 Newton.
صح.
And this 10 Newton affects the blue box. Is that
No,
correct?
no. That 10 Newton is consumed by the green object to accelerate.
Okay, so what does that mean?
That means the green object will consume only 10 Newton to accelerate, and then it will pass to the blue object 5 Newton.
Okay. And what do we do next?
Well, we are interested in the contact force. We need to know the contact force. The remaining 5 Newton is the contact force.
Okay, so there's no need to calculate the force on the blue box, just like how we did.
Well, the blue box force is F is equal, net force is equal MA. You can calculate it at any moment. Well, in this problem it is clear, but sometimes in other problems it is not clear, so you need to calculate it.
So what are you trying to say, that we can calculate the contact force by using two different methods?
You calculate, if you calculate the acceleration needed, if you calculate the acceleration of the second object, then you can deduce the force acting on the second object.
Okay, so in summary, if we want to calculate the contact force, we calculate the net force on the first object, then the remaining force from the total force is considered as a contact force.
That's correct.
Okay.
That's correct. Because this is a situation where you have only two objects. But if you have three, you need to do the same methodology on the third one.
Okay, so that's why we calculated the
Exactly.
force on the second object.
Exactly, because if you have three objects, then you apply the same methodology on the third object.
Yeah, I got it.
تمام؟ هلا خلص الوقت ما شاء الله. الواحد لما يحكي على الفيزيكس بنسى الوقت. هلا باخذ الحضور. بس لاحظوا احكي لكم شغله. هلا ادرسوا المثال هذا كويس قبل الحلقه، قبل الحصه الجايه، لانه if we apply the force from right to left everything will change. So don't confuse yourself, at least understand this situation, and then inshallah next lecture we'll apply the force from right to left and the contact force will be different. No, we didn't finish chapter 5. Chapter 5 is very, very long. Still, we have to reach. We have another, 2 or 3 examples? Yeah, we have another 3. We have another 3 typical examples, and then we enter into the friction. So still, chapter 5 is very long. طيب خليني أوقف التسجيل.